Okay, so welcome back to the tutorial. So one of the things that we were looking at yesterday in the workshop was related to looking at correlation and regression of our attendance data. So I'm assuming that most of you can calculate and work out a representation of the data using a scatter plot and define a trend line using the trend line tool, and also identify the equation on the chart, but also the R-squared value, which helps indicate the relationship between the data sets. This thing obviously gives us a correlation, i.e. how much or how strong is the correlation between performance and attendance, or attendance and performance. We can also use the data analysis tool pack to develop or identify our R values, which really do account for our correlation between the two data sets. We do that simply by selecting within our data tool pack correlation, and we have an input range, and our input range is simply all of the data points relating to each of the columns of data that we want to analyze. And we're going to just choose an output range. In this case, I'm just going to put it next to the previously formed correlation. And here we now have our correlation. So again, obviously, you would change the title so you actually know what you are looking at. So when you come back to refer to it, it's self-evident, and you can actually identify what it is you're seeing. And obviously what this table is doing is essentially comparing each of the data sets for a correlation. And we'll give you an R value for each associated data set. So in this one here, we're looking at attendance versus case study, attendance versus CBA, and attendance versus the total. And these are all respective R values. So attendance versus the CBA has a positive correlation. Attendance versus total has a mild positive correlation too. And obviously, when we look at interactions between case study and CBA, it has a negative correlation. So it gives you an overview of each of the individual columns of data and their respective correlations to each other. But obviously the problem with this particular data set is that it doesn't really account for any error within the correlation, i.e. how far these data points spread from this trend line. All it gives you is an overview of that trend line. So a correlation of 1 is where you have from 0 to 1, or you have a direct relationship, a true relationship between the data points, which is why when you plot attendance versus itself, it'll have a positive correlation to itself, with a R value of 1. So in order to actually start asking questions about the data points and how far those data points are away from the trend line, we need to look at regression analysis. So I've done some regression analysis here, and simply put, what you need to use is the data analysis toolpack again, and you can use, where's it gone, regression here. In regression analysis, your input range would be, first input range would be attendance. Let's choose that there, and your second input range will be, in this instance, I'm going to choose case study. And because I've included the top line here, I've added a label, so I'll label it automatically. We're asking for 95% confidence intervals, and I'm simply going to place it back here. So it should overwrite this data nicely for us. So I'm just going to click OK, and it'll ask me, do I want to overwrite? And I say yes, and here's our output. So in order to describe the output, what I've done is I've provided some notes here, and I'll give you this Excel spreadsheet for your revision. But ultimately what we have is we have a multiple R value, which is equivalent to the correlation value that we had here on our previous analysis. And the correlation coefficient is basically just saying how linear that relationship is. I spelled relationship wrong here, so let's change that. So it tells you whether it's a positive relationship and how linear it is in general. The R square is exactly what it says, so it's the R times R value, so it's the multiple R times by itself, and it's the coefficient of determination. So what this basically means is how big an impact will a change in X or Y make on the other variable. There are other values that are also included in the output, such as an adjusted R square, and that's if you have multiple X variables within your data set, so you're using a number of different data sets. And then obviously the observations that you have will be how many data sets we have, so n equals 51. Yeah. And so that gives you the sort of kind of regression statistics. And then we have a bit of a statistical analysis using the ANOVA. So the SS relates to sum of squares. The MS is sum of squares divided by the degrees of freedom. The F-test is just simply that, the F-test. And obviously the significance relates to the p-value for the F-test. But generally speaking, the F-test and the significance F aren't really used in normal sort of kind of statistical use of regression analysis. What is used, however, is this table here. And it's this table here that gives us an indication of the relationship and how close that data set is to the line of your trend line, essentially, of your correlation and regression line. So the coefficients, this are basically a sum of least squares estimate. The standard error is the standard error of that sum of least squares estimate. T-test is obviously the t-statistic from the development of that sum of least squares. And then the p-value is really the statistical evaluation of the null hypothesis. So if it's greater than 0.5, so if p-value, p equals greater than 0.05, then you accept the null hypothesis. What does that mean in essence for this piece of data? That the associated relationship between the two data sets is not significant, i.e. there isn't a relationship between the two data sets. And that's an important judgment to be able to make, because you're not just looking at how strong the relationship is you're looking also at the impact of that relationship, if you like, or the significance of that relationship. So that describes obviously the attendance versus case study data set. I've already done the statistics for the case study, attendance versus the CBA, which is this one here, for the regression analysis. So you do carry out basically the same analysis. And one of the key things just to highlight is actually the data set here, which is the p-value is p equals less than 0.05. So in this instance, we actually reject the null hypothesis, and we can state that there is a significant relationship. I wish I could type hypothesis. So we can state there is a significant relationship between attendance and test performance, if you like. And so obviously what we can do is we can continue the analysis to look at, well, actually, what is the impact of attendance versus total? Now, in terms of attendance versus total, we have a p-value of 0.08. So that basically means that we're getting close to the actual requirement of a p-value that equals less than 0.05. But in this instance, obviously, if you're thinking about the relationship between attendance and performance, you may want to adjust your significance level, because at the end of the day, you want to have a look at how impactful on a group of individuals. Now, you might want to actually say, we want to go down to a 10%, a p-value that equals less than 0.1 as our criteria for our statistics. And you might be justified in doing that because you're utilizing the data in a way that's affecting human performance or will inform human performance, essentially. Okay, so that's the end of the video, and I will catch up with you another time.